Now, moving ahead to the next segment, I'd like to call Rishi to introduce Pankaj Mehra, who will be talking about inventing in context. A great conversation coming up. Let's go ahead, please.
Hello, I am Rishikesh Sarthone. I'm on the board of IIT Bay Area as the sponsorship chair. When I joined Western Digital a few years ago, I was looking forward to working with the storage industry CTO icon, Pankaj Mehra. But he moved on to Samsung even before my start date. He eventually hired me into Samsung, and the way he mentored me during the hiring process, I was thrilled to be able to finally work with him. Within a couple of weeks, though, he moved on to his next venture, so I will have to wait. Today, I am thrilled to introduce Pankaj to you all. Pankaj Mehra hails from the first computer science batch at IIT Delhi, where he was later a tenured faculty member. In between, he got his PhD from Illinois and did his Swadesh stint at NASA. Pankaj has a century of patents and papers. In the 1980s, he pioneered the use of machine learning for measuring and modeling large-scale systems. In the 1990s, he open-sourced performance tools, came up with virtual switches, and switch-based virtualization in his company IntelliFabric. In the 2000s, he was promoted to HP Distinguished Technologist for inventing persistent memory. He started HP Labs Russia as well. In the 2000s, he created Houdini, an email and calendar mining startup. He was appointed worldwide CTO at Fusion.io. In the last few years, Pankaj pioneered computational storage at Samsung with the project called Smart SSD, which won the 2021 CES award. Currently, he's working on disaggregated memory, which he calls the last resource to virtualize in a data center. Well, I will continue to wait to work with him, but you don't have to wait to hear from him. Friends, here is Pankaj.
Hi, Rishi. And thank you for that introduction. I think I'll have a tough time keeping up with all that you had to say about me. But time is short today, and we have a really important thing to talk about. Thankfully, there have been some really great speakers who have gone ahead of me. And in fact, just in the panel before, if you were in the CTO panel, they talked about persistent memory. So my job is easier. So I, like a good engineer, before I became a business person, I actually like to define the terms I'm using. So you are all inventors, but success in invention is something I'll define in my subsequent slides. Here, I wanted to discuss with you what is my view of context. So context is like a flower. Some people say it's 7 dimensions. Some people say it's 19 dimensions. But it's basically, everything that has happened before and how that affects your perception of what you do, what you own, what you look at. And it's best looked at in terms of rolled out in space, in time. So, context is an integration in space and time. And your immediate, situational context is shown to the right. We can think of it as small context, like, a meeting you're in or a task you are doing. And that generally, is the context in which most inventors work when they're young. But more seasoned inventors, they work at the scale of industrial events or even science level achievements. So they have a sense of what is the history and global scope of some fields of knowledge and scientific and professional communities, and what it constitutes to have the highest level of competency. And they really invent in the large context. And my view is that to do justice to big ideas, should they occur to you, which I think they will occasionally, you have to give them fertile ground. You have to see the seeds of that idea blossom in your head. You have to recruit other people. And then you have to even, stay in the game to build things and sell them. So that's what, invention at its highest level becomes entrepreneurship. So let's keep going. So let's build upon this metaphor of a seed producing apples and then fruiting. But rather than tell you a lot of success stories right away, I actually want to share with you some upper body scars that I have encountered as an inventor, where I had some great ideas. Like, some people credit me with coming up with the idea of Google Glasses. When I was at HP Labs and Prith was, running that panel, I proposed to Prith that we should build glasses that see everything you see and hear everything you hear. And I proposed the idea of an intuitive context engine. Due to, I will blame lack of personal commitment and sometimes not communicating properly, not recruiting other minds. Sometimes good ideas can fail. And you can see that was not an easy idea, that Google Glass itself was not a resounding success. And now Facebook is betting their future on that. But, there are other times when you actually get to a good idea. I'll give you an example of my company, Houdini. We actually, raised capital from angels. Within 2 years, we had offers to be bought out by Jive first and then by SAP. But, we did not address privacy deeply in that company. And we were mining email and calendar data. And in my opinion, Houdini would have been a much bigger success if we had not left the privacy long pole unaddressed for so long. So sometimes, you go even further and you actually have a tree. So now, you have something, but if you are too early to the market, you're not going to find any customers. So as an entrepreneur, rather than an inventor, I would rather, be second to the market than be first to the market and be super early. Some people feel proud of that. I used to be very proud of my inventions where I was really early. These days, I'm not. I would rather I come up with inventions that, have customers and people who benefit from those inventions right away. And so that's, more perfect. And then finally, I'm going to just reiterate a quick comment from Bill Gates, who pointed out that, humans have a tendency to underestimate the long-term potential and overestimate the short-term potential of the technology. And this I want to, build upon in the next slide. What does it take to actually realize the long-term potential of a technology? And I call that reaching the Kamdhenu stage. So, in our culture, in my religion, there is this idea that, you can have a gift that keeps on giving, or, a cow that grants all wishes. But that's really metaphor for, something so good that you can keep milking it. Okay. So how do you get there? And, what does that journey look like? And by no means I'm claiming that, I'm all the way there, but I'm willing to share with you. I am so glad that, in the events that happened before this panel, that somebody went ahead and talked about how important is persistent memory to their future. Actually, for me, persistent memory is something that I started working on in 2001. And, there was a keynote I gave at one of the conferences where I talked about server architecture. And I talked about that, we will need persistent memory because there is this thing called the storage gap, that transactions need shorter latency and better persistence. And, we built persistent memory devices and file systems in about 2004. I wrote my IEEE paper, coined the term persistent memory at that time. Later, I was CTO of the company Fusion.io, and we still, in 2013, built persistent memory. And it was one of the reasons why SanDisk bought us. And, I've continued working in this area. Even while I was at Samsung working on SSDs, I actually worked on persistent memory technologies called persistent pointers in my own time. And in 2020, that won the Best Paper Award, Best Presentation Award at Usenix Advanced Technology Conference. And so, I've kind of listed at the x-axis here the idea of success, that as your notion of what success is broadens, you start to actually do things that give you, bigger successes which are shown on y-axis. Initially, your achievement is very personal and you're doing things so you can have something to your name. Later, you start working cross-functionally and you solve other people's problems within the company or your customer's problem together with other functions in your company. At some point in time, you have enough conviction in your ideas and you have infected enough minds that you can, spin off and form a venture or get incubated inside. And all of those things happened to me. For example, in HP, we were working on context-aware computing. At the same time, I was having these ideas about Google Glass and all, and we got incubated as taxonome.com. But, many times these inventions, they reach like, an improved product, or you're given a new team, new incubation, but they don't go anywhere. Okay, for the reasons I listed on the previous slides. In fact, sometimes, downright, as you leave and form ventures, and then, you form a startup and you don't get to the acquisition that you wanted. Sometimes it's bad luck. Sometimes it's things that, should have done, did not do. So I, can you tell you many stories, but I just want to end with, some ideas that I'm continuing to work on persistent memory. And there are a lot of believers, many big companies, including Oracle and some big virtualization companies that believe in what I'm doing and working with me, sometimes as customers, sometimes as partners. So in parting, what I want to tell you is that, to go to these big successes, you have to realize that one brain is not big enough to do justice to big ideas. I mean, it takes a field to grow a forest. You have to write, you have to share, you have to open source, take positions, review and advise, recruit. If somebody tries to give you money, take it and build the next piece that you need to build. Always be raising. You have to learn from others and not repeat their mistakes, make new ones, like my co-founders used to say. And it's important to realize that it's the inventor's responsibility to grok the larger context of work. And you have to have the energy, commitment, and perseverance to keep an idea alive and growing. That takes, I always like my Israeli friends, Voltaire worked for 7 years before they had an IPO, and then continued working through the acquisition by Mellanox. And then, those guys are still driving that as part of NVIDIA 30 years later. It takes energy to make transformational change in our industry. And you have to define your own notion of big success and pursue that relentlessly. You know that Amazon, if they hadn't chosen the word Amazon as their name, they would have chosen the word relentless. And many people have said today earlier that, please read Clayton Christensen. He is the teacher that teaches how to manage the process of successful innovation through all the way to disruption. And with that, let me open it up to questions. And you have some pointers here how you can find me on LinkedIn and Facebook and follow me. Thank you so much. Rishikesh, do you want to come in and look at some questions that are in? Maybe one?
Yeah, so we have a question. And the question is, what motivated you to create such a big breakthrough in the history of networking with PC internet access, first in the world?
I didn't create that breakthrough in the PC and networking world. I used advanced networking with memory semantics to connect memory to memory semantic networks. When we used to do networking before, we used to have two-sided handshake, which is a CPU here and a CPU there would have to burn cycles to move data. With some of the things like RDMA and other things, I was chairman of InfiniBand Standard, one of the working groups. And we invented this technology like RDMA. And my big idea in 2001, 2002 was that we could connect memory that would hold persistent media. And we could replace disks and flash with instead memory semantic access to transactional writes. So that was the birth of persistent memory. And later, Eric Brewer, who was the founder of Inktomi, then at Yahoo, he's now VP of infrastructure at Google. He taught me that persistence has nothing to do with non-volatility. In fact, he said, if you throw data to the four winds and it sticks in enough places, you have persistence. Okay. And so I learned that, and I then refined my idea of persistent memory down to the idea of persistent pointer. Then I gave technical talks about that at UC Santa Cruz, and one of the students really liked that. So he put me on his thesis committee, and then he rewrote FreeBSD to implement a new operating system called Twizzler that we open sourced last year. And he has become my intellectual successor. And this actually I consider the epitome of technical success, which is if an idea can live past my life as an engineer and continue to infect other engineers and keep working, that is where you can have decades-long success. So I could have done that as a startup founder. I could have done that as a manager. I just happened to be on a thesis committee this time. Okay.
Thank you. So we have a second question. How to know when to be relentless and when to quit?
Yeah.
How do you know when the idea is worth pursuing, essentially?
So I think, you have to listen to people like Kamal Rekhi, which is that brutal honesty, sometimes, boiling down to numbers, is your answer. And you should aim for early failure rather than late failure with bad ideas. Okay. So startups have that culture. Good startups have a culture of brutal honesty and collegiate dialogue. And I remember, there was a time I had a co-founder, and we founded something that looked like YouTube in 1998. So you can also make a mistake in quitting. Okay, that's why I emphasize relentlessness over quitting. I founded something called Splash Technologies and landed Skyhook, which was actually HP's photo service, as my first customer. But it was not a video company, and I wanted to do a video startup. We couldn't find a customer for our video streaming service, and we quit before the internet became fast enough to have a service like YouTube. And so relentlessness is avoiding that mistake. And yes, sometimes you do have to quit, but many times you just have to be bullheaded about it and just keep going.
I remember a book which talked about the KFC founder who kept on trying his recipe for more than 2,000 times, and eventually he got a success. So that goes back to being relentless and keeping at it.
That's correct. That's correct.
So you talked about, you get bogged down by your work. You're probably developing something new, but there are two levels to the innovation. One is like, your immediate thing, and the other is broader industrial trends and things like that. So how did you actively try to find time to keep in touch with those? Do you have like 1 hour saved every week, or what's your strategy to be able to keep in touch with those broader trends?
So there are two things you have to do. This session is very tight, and I have to respect you guys' time. One is you have to vote with your feet. So when you are in a company that cannot support your big idea, you have to vote with your feet and go out and leave and pursue that idea elsewhere. Second is that if your company will let you pursue your idea as a product, that is the best. Actually, HP, even when it was a hardware company under Prith, it had incubated my venture called taxonome.com in context-aware computing. And we landed customers like LexisNexis and Bloomberg and others, okay, paying customers, okay, as an independent domain name, independent service. But later it became clear when I came up with glass-like concept and intuitive context engine that HP could not keep going there. So in 2010, I left along with some other HP people and founded Houdin. Okay, so you kind of have to, play it both ways, which is watch out for alignment with your immediate context. And, if sometimes the context is more important, sometimes the idea is more important, and you have to weigh that and place your bets. Okay.
Thank you. One of the famous examples of persistent memory is 3D Crosspoint, and we all know it kind of went down south. Intel was actively working on it. It had everything, processor, pretty much the whole ecosystem under its control. So what did they miss?
Yeah.
The 3D
It's very
cross-point.
interesting question. People, Rishi, have been working on phase change memory since the 60s. Okay. When I was inspired to work on persistent memory, it was because of some work that was going on at a company called Mnemonics that was variously acquired and changed hands between Intel and Micron and eventually became 3D Crosspoint in 2015-16 as a public technology. But it has been worked on since the time I worked on persistent memory. They were working on non-volatile memory. And I wrote a Wikipedia article about this, so I'll not go on for long. You read my Wikipedia article about persistent memory. And what it says in a nutshell is that persistent memory is about 90% about software. That non-volatility is not persistence, and persistence is not non-volatility. Persistence is an architectural concept like Eric Brewer taught me, and I took that to heart. So I focused on the software aspects of persistent memory, and Intel did not learn from me. They did not read my papers and kept focusing on the device aspect of it. They didn't get anywhere, and the ideas of people like me and companies like Oracle are actually going much further because we focused on software first.
Right. So what you're saying is the eventual customer is software guys, and you focused on what they consider as their definition of persistence and not what
No, I'm saying that the
persistence.
product is software first and memory later.
Yeah.
That I can build persistence with enough replication using DRAM, or with disaggregation like I'm doing in my new company, I can build persistent pointers. I don't need non-volatility. I don't need 3D crosspoint. And the beauty of 3D crosspoint, it is cheaper than DRAM, not it's non-volatile. It took Intel many years to understand that, and they lost their market opportunity because of that. I wish they had, listened to me. Actually, Alper and other people who run it there, they're good friends of mine, and I had this discussion with many people, but unfortunately, they were not willing to listen to me.
So you have a told you so moment.
Well, I mean, they could have a told you so movement later. So we are still playing it out, battling it out.
All right. Well, those are all the questions we have, and I think.
All right. Thank you.
Thank you so much, Pankaj. It's always a pleasure to talk to you.